problem reads that Jade is 2 miles offshore in a boat, and she's trying to reach a village that is 6 miles down a straight shoreline. We're trying to from the point nearest her boat. She can row 2 miles an hour and she can walk 5 miles an hour. And we're trying to find where she can land her boat in order to reach the village in the least amount of time. So here, let's draw a visual of this. So here we have little Jane in her boat. She's in the river and she is 2 miles from the shore. So we're just going to label this as 2 miles. So we know that the shoreline is straight, and it is straight for 6 miles. A little raggedy. I'm going to call this 6 miles. So she's going to be rowing to a certain point to get to the shoreline, and then she's going to walk the rest of the distance. So we're going to call this distance along the shoreline, which she rows to, x, and we're going to call this remaining distance 6 minus x. So here we also have to find what is this distance that she's rowing? Well, using Pythagorean's theorem, due to the fact that this is a right triangle, we can find out an expression for that distance. So we're going to say 2 squared plus x squared is going to be equal, I'm going to call this c. So c squared. So c is going to be equal to the square root of 4 plus x squared. And here it's going to be the positive square root because distance is positive. So we have these measures of these distances, well, these expressions for distances, but we're trying to find where she can land her boat in order to reach her village in the least amount of time. So here we're going to write an equation dealing with time. So we know the total time that it takes is going to be her rowing time plus her walking time, because she's first going to row a distance and then walk the rest to the village. So we know that she can row at a rate of 2 miles per hour, and she can walk at a rate of 5 miles an hour. Now here, if we're trying to find an equation of time, we have some expressions of miles and we have some rates of time. So how can we relate the miles in miles per hour in order to get just strictly hours? So here, we're going to take miles in this. We have miles per hour, but we want hours. So how do we do that units wise? We're going to put the miles in the bottom and the hours on top. So here, using this conversion, our miles are these expressions. So her rowing time is going to be the square root of 4 plus x squared over her times, I'm just going to write it out. So we're going to have 4 plus x squared, the radical 4 plus x squared, times her miles per hour, the reciprocal of it. She rows at a rate of 2 miles an hour. So that would be times 1/2, which is the same thing as dividing something by 2. So here we have her rowing time, and her walking time is going to be 6 minus x times 1/5, or divided by 5. And so this is going to be the equation that we are going to be taking the derivative of in order to find the least amount of time. So take the derivative of this. We're going to have the derivative of both sides. T prime is going to be equal, I'm going to use the constant multiple rule to factor out this 1/2. Now we're going to take the derivative of the square root of 4 plus x squared, which is going to be 1 over 2 times the square root of 4 plus x squared, all that times 2x. By the chain rule, we're going to add, I'm going to factor out this 1/5. The derivative of 6 minus x is -1. So here, t prime is going to equal, so 1/2 times 1/2 is going to be 1/4, and 2x over 1/4 is simply x over 2. So we're going to have x in the numerator over 2 times the square root of 4 plus x squared minus 1/5. So here we have our derivative, and when we're trying to find the minimum value of this t, we're going to set this derivative equal to 0. So I'm going to carry that out over here. So we're going to have 0 is equal to x over 2 radical 4 plus x squared minus 1/5. So the first step here in solving for x would be to add 1/5 to both sides. So 1/5 is equal to x over 2 radical 4 plus x squared. Now we can either cross multiply, or we can divide by x or multiply by 1 over x on both sides. So I'm going to multiply by 1 over x on both sides. One over x times 1 over 5 is 1 over 5x. Here the x's cancel out and we'll be left with 1 over 2 radical 4 plus x squared. Now here, since we have the reciprocal of both sides, we can just go ahead and reciprocate them. So now we'll just get 5x is going to be equal to 2 radical 4 plus x squared, which is the same thing we would have gotten if we would have just gone ahead and cross multiplied here, making that 5x is equal to 2 radical 4 plus x squared. So here I'm going to go ahead and square both sides in order to get rid of this radical. Five x squared times 5x squared is going to be 25x squared, which equals 4 times 4 plus x squared. Now here, I'm going to go ahead and distribute this 4 right here. So 25x squared is equal to 16 plus 4x squared. Next, we subtract 4x squared from both sides. So 25x squared minus 4x squared is 21x squared, which is equal to 16. Now we're going to divide both sides by 21. So x squared is equal to 16 over 21. Now we can take the square root of both sides. Now when we take the square root, be mindful that we usually take the plus or minus square root, the positive and negative version of it. But here in this problem, we notice we have to look back at our domain because we have to make sure that x, the value that we get for x, is going to be a part of our function's domain. So we know that the domain here, I'm going to write it here, is from 0 inclusive to 6 inclusive. So our x's can only be between 0 and 6, and can be those numbers as well. So here we're going to take the plus square root, because if we took the negative square root, then it would not be in our domain. So here x is going to be equal to the square root of 16 over 21, and we can write that as 4 over the square root of 21. And this, we have to attach a unit because we're trying to find where Jane should land her boat along this shoreline. And we said that she should land her boat in order to take the least amount of time at 4 radical 21 miles. So here x is equal to 4 over radical 21 miles. And that is where Jane should land her boat in order to reach the village in the least amount of time.